Hello everybody, it is time for us to take a look at worksheet 4-2 and buckle up because this one is going to get complicated, I guess. Not really, there's just a lot to do on this worksheet. This might be kind of a long video, we will see. Starting with number 12, what are the measures of angle 1 and angle 2? Explain. Well, of course, we have an isosceles triangle in here, and not an isosceles, an equilateral triangle. And we know that all equilateral triangles have angles of 60, 60, and 60. So we know that if this is a 60-degree angle, this exterior angle is going to be 120 degrees. And because the lines are parallel at the top and bottom, we know that angle 1 and angle 2 are same side interior angles, which are supplementary. So angle 1 is also 60 degrees. There's other ways to come up with that as well. So the measure of angle 1 is equal to 60 degrees. The measure of angle 2 is equal to 120 degrees. And we used same side interior angles and exterior angles to find that out. Number 14, prove that BAD is congruent to BCD and ABC is congruent to CDA. So notice that's telling us the opposite angles. BAD is congruent to BCD and ABC is congruent to CDA. However, the proof for the left hand and right hand angles is going to be the same as the proof for the top and bottom angles. So we're just going to do one half of this proof. We're just going to prove the left hand and right hand angles are the same, because then we could do the same thing if we wanted to prove that the top and bottom angles were the same. So we just don't need to write that part. So let's go ahead and make our T-chart. Alright, so we've got some information in the diagram that can be our given information. So that would be, let's see, if we were to make a line, and I guess this is a part that we should probably do, is we should create a line like this. And if we make a line like that, we make this into two isosceles triangles. We can see based on the markings that they are isosceles. All right. Do I want to make that? I don't want to make that. I want to make the other way around line. See, this is what you get for a real-time video of me doing the homework. There we go. So we made, again, two isosceles triangles. Interesting, it seems, that we want to make this line going this direction when we're actually going to be talking about this angle and this angle, but you'll see why. So making these isosceles triangles tells us that angle BAC is congruent to angle BCA and angle CAD is congruent to angle DCA. Both of those are because of the isosceles triangle theorem. The isosceles triangle theorem is the one that tells us that the base angles of an isosceles triangle are congruent. Okay, so that means, let's see. Thinking instead of talking or writing. There's what we've got so far. And again, that's based on the isosceles triangle theorem. So the next thing that we can do, once we know that those two are the same, we can say, well, if I add an angle with one arc and an angle with two arcs, and over here I add an angle with one arc and an angle with two arcs, then those angles should be the same total, right? The total angle over here should be the same as the total angle over here because each one has one arc and two arcs. So that's what I'm going to write in my proof. I'm going to write the measure of angle BAD is equal So I'm doing this in 2 steps. The whole angle is equal to the measure of angle BAC plus the measure of angle DAC. And in the same step, I'm going to do the same thing for the other side. I'm going to say the measure of angle BCD is equal to the measure of angle BCA plus the measure of angle DCA. And I know that those angles, those bigger angles, are the same as the 2 smaller angles added together because of the angle addition postulate. And then 3. Because I know that these angles, this one and this one, are congruent, and I know that this one and this one are congruent, I can say that the measure of angle BAD is congruent to the measure of angle BCD. And I can just do that by substitution. Now notice that I didn't say the angles are congruent yet. I'm proving that the angles are congruent, and down here I have the measures of the angles are congruent. So I can do one last step to go from the measures of the angles to the angles themselves. I can say angle BAD is congruent to angle BCD. And I know that by the definition of congruence, that's the one that tells us that if the measures of 2 angles are the same, the angles themselves are congruent. So it's going to be the definition. Definition of congruent. I am also going to go in here and take out this squiggle at the top of this one, because the measures should be equal and the angles should be congruent. All right, number 15, Amaya is asked to find the side lengths of the triangle shown. What is her error? So she said from the top leg and the base, 2x equals 6, so x equals 3. However, where these 2 angles are the same is going to be this angle and this angle, which means the side lengths that are the same are the 2x and the 3x minus 5. So she should have said 2x equals 3x minus 5 to solve for x instead. She should have said 2x equals 3x minus 5. And that would give her the correct answer. Let me rewrite that. That makes me really sad when things are that messy. 2x equals 3x minus 5. I don't know if that's better. Whatever. Okay. Number 16. This one we are actually going to skip. I don't know if it's going to be on your worksheet or not. I'm going to try and take it off. But we're not going to do number 16 because it doesn't really add much to our discussion of isosceles and equilateral triangles. Number 20, find the lengths of all 3 sides of each triangle. Of course, if I know this is an isosceles triangle, I know that 20 and 4x minus 12 are the same length, so we'll set those equal to each other. And then just solve that equation. X equals 8. So when we plug that into the 2 sides, 4 times 8 is 32. 32 minus 12 is 20. So that side, of course, is 20, which we already knew. And 3x plus 5 would be 3 times 8, which is 24, plus 5, which is 29. Number 22. What is the measure of angle DEG if the measure of angle DFE is 70? So if we go in here and we say DFE is 70, and we want to find the measure of angle DEG, and we see that these 2 angles are congruent, then we know that these two triangles are going to be congruent, which means that over here, this is also going to be a 70-degree angle. So we can look at the whole triangle DFE, and we can say this is going to be 180 minus 70 degrees minus 70 degrees gives us 40 degrees left over. So the measure of angle DEG is half of that, right? So the measure of angle DEG, look where it is in the, there we go, in the shape DEG equals 20 degrees. And we are also asked, what is the value of B if A is 8 and C is 24? Well, if A is 8 and C is 24 and we have this shape right here, it is going to have right angles, which means if this is 8, this is 24, we are going to be able to use the Pythagorean theorem to solve for that shape. So we've got 8 squared plus x squared, because B is going to be the medium length side, equals 24 squared. That's going to be 64 plus x squared equals 576. I would say it's important for you to memorize your square numbers up through like 30, just so you can do them off the top of your head. Subtract 64 from both sides. X squared equals 512. And then we take the square root of both sides. X equals the square root of 512. All right. And if we wanted to make that a decimal, that would be around 22.63. So either way, we could make it the decimal version, or we could make it the exact answer version over here. So doesn't matter. Let's keep going. Number 25, given the measure of angle PSR is 134, what is the measure of angle SQR? Well, in this case, we have a shape that is an equilateral triangle. All three angles are the same. So we know that the angle measured on here is 60. But if the measure of angle PSR is 134, then we can just do 134 minus 60, which is 74. So the measure of QSR is 74. But of course, QSR is an isosceles triangle. We have two angle or side markings here, which means that we know that this angle is also 74. We're asked for the measure of SQR, so we can do 180 minus 74 minus 74 to find the measure of that missing angle there, the remaining one, and that is going to be 32. So the measure of angle, my angle signs, man, the measure of angle SQR is equal to 32 degrees. There we go. Number 26. Each of the 5 points on a star produced for the flag is an isosceles triangle with leg length 6 and a base length 4.2. What is the total height h of each star round to the nearest tenth? So we're looking for the total height. We have this idea with the leg length 6. So let me get a different color here that'll show it better. Leg length 6 like that, and a base length 4.2. So the whole base across is going to be 4.2. So if I just took half of that base, because I want to try and find x. I want to try and find the height of this triangle. So I'm going to make half of that star point. I know it's a right angle right there because I took an isosceles triangle and I made an angle bisector at the top. So that's going to be 6 and half of 4.2, which is 2.1. So to find the length x, I'm going to use, of course, the Pythagorean theorem. So I'm going to say 2.1 squared plus x squared equals 6 squared, which is going to give me 4.41 plus x squared equals 36. So I've got x squared equal to 31.59. And I want to take the square root of both sides. That'll give me x equals around 5.62. So my height of the point of that triangle is 5.62. And the remaining height in this star is 8.5. So all I need to do is 8.5 plus 5.62, and that is going to give me 14.1. So my answer is 14.1 centimeters, right? So it's around the nearest tenth. So make sure that that's what you did. Oh, that's not a rectangle. Also not a rectangle. There we go. Okay. Number 27, the front of the tent below has the shape of an equilateral triangle. What is the side length of the triangle? Round to the nearest tenth of a foot and explain the method you used to calculate the length. So this is tricky, okay? This is tricky because the only number they give you is the height of the triangle. They don't give you either one of the sides. So how are we going to use the Pythagorean theorem to find the side lengths of this triangle if we don't know either one of the sides? Well, we know it's a right triangle when we split it down the middle, and we know that because we took an equilateral triangle and we made an angle bisector. So it's a right triangle. We also, if we wanted to, we could call one side of this triangle x. We could call the short side x. And if you think about an equilateral triangle, half this side is going to be x. So the entire length of this side would be 2x. And if the entire length of this side is 2x, then the entire length of this side is 2x as well. So that is going to be called 2x for right now. So what I can do, I'll bring it up here and do my work at the top of the next page, is I can draw half this triangle. I can draw the right triangle portion of this triangle. That. So I've got the right triangle, and I've got x, I've got 2x, and I've got 5. So for part A, I want to use the Pythagorean theorem to solve for x. And the way I'm going to do that is I'll write x squared plus 5 squared, the median length side, equals 2x squared. And I'm putting that in parentheses to remind me to square the 2 and also the x. So this is going to be x squared plus 25 equals 2x squared is going to be 2 squared, which is 4, x squared, which is x squared. Then I'll subtract x squared from both sides. Gives me 25 equals 3x squared. Divide both sides by 3. And I'm going to get 8.3, repeating, equals x squared. Take the square root of both sides. And I get around 2.88 equals x. Okay? But that's not the answer to the question. That's just how long x is. Okay? So x is 2.88. 2x, let me do this over here. 2 times 2.88 is going to give me 5.76. That is my final answer, because that is the length of one side length of this tent, one side length of this triangle, right? Because 2x is the side that's double the x that I found. So if I'm writing an explanation, says, explain the method you use to calculate the length, I'm going to write that I use the Pythagorean theorem. Use the Pythagorean theorem with x and 2x as the side lengths. Alright, that's kind of a tricky thing that you might not see the first time through, but you can always take an equilateral triangle, split it down the middle, and call this side x and this side 2x every single time. That could help you solve other problems. 29, consider the following triangle. Write an equation you can solve to find the value of y. So if I know that this is an isosceles triangle, I know that those two base angles are the same. So I can write that 5y minus 19 equals 56. And b, what is the measure of angle K? Well, we'll have to figure that out. We can say, if I know that the angle M is 56, I know the angle L is also 56. So to get K, I would do 180 minus 56 minus 56, right? Unrelated to part A, and that gives me 68. So the measure of angle K equals 68 degrees. There we go. And finally, number 30. This one is very similar to a problem we had earlier in this worksheet, like almost exactly the same as the first problem on this sheet. Given the measure of angle ABC equals 114, what is the measure of angle BAD? So if ABC is right here and it's 114, we know that this angle is 60 because that's part of an equilateral triangle. So we'll call this 60, and then we can do 114 minus 60 and find out that this angle right here is 54. Right? And we want to find the measure of angle BAD. Well, I know that this is an isosceles triangle. So if this angle is 54, these angles are the same as one another in an isosceles triangle. I can do 180 minus 54, right? And that is going to give me 126. That needs to be split evenly between my two other angles. So 126 divided by 2 is going to give me 63. So each of my two base angles, including angle BAD, is going to be 63 degrees. All right, and that is everything for this worksheet. I know it's kind of a lot. If you've got any questions, please let me know, and have a wonderful day.